You are invited to imagine, discover, and explore by taking part in STEAMFest 2021, an online event starting January 30th that is free and open to the public. Explore scores of engaging hands-on activities in science, technology, engineering, arts, and mathematics, including science experiments, art projects, building challenges, outdoor adventures, and live stream events. This year, online activities have been created by students, parents, teachers, and a range of sponsor organizations, including NASA, Google, several popular YouTube creators, businesses, and a number of community organizations. Join us in this family-friendly celebration by sharing on social media and with family, friends, and coworkers, sponsoring or creating activities, and of course, register your children to participate as STEAM explorers.
Greetings, everybody. Lee Blakely here again from STEAMFest Central. We're in the control room. We've got an exciting program today. We've got Christian Eggleston, science teacher, chef, master cooker of eggs, who's going to take us through a lesson on how to cook an egg and maybe mix a little science into it also. So I'll hand it over to Christian and we'll get this started.
Awesome, Lee. I think Lee's being a little gracious when he says master chef, master cook. I have recently learned to cook, but one of the things that I've always understood is that science can help me do things better. And so having a better understanding of the world around me can help me appreciate what I'm doing a little bit better, help me do the things that I'm doing a little bit better. And one of the things that I realized once I started cooking a little bit later on in life as I became an adult and started having to take care of myself is that I've been cooking certain things wrong my whole life. And one of those things was eggs, right? And as Mr. Blakely says, that my last name is Eggleston, and so that seems almost like a shame, right? So I'm going to take you through today, on how science can help you actually cook a little bit better, right? And so the most important thing that I learned about the way that I was cooking eggs, all right, was that my understanding of heat was actually really, really poor when it came to cooking, all right? And so the first thing that I want to do, all right, is I'm gonna preheat my pan. Sometimes even if I'm teaching someone for the first time cooking eggs, all right, I'll even tell them to start with a cold pan. But the biggest thing is I don't want to burn my eggs. I realized that what I had been doing had been burning my eggs, had been starting the chemical reaction that happens in the eggs just way too soon on just one part of the eggs. And because what happens when you cook something is that a chemical reaction actually happens. We can see that through a couple of different signs. One is that a new substance is formed. We see some changes of state. The type of reaction that happens if you're an upper school student is called a denaturing reaction. So the proteins in the egg are actually going to break down and change shape. And so I don't want that to happen too fast in just one part of the eggs, and then eventually that gets burnt while the other eggs are just finishing. So I'm going to start pretty low. I have an electric stove. All right, I'd love to have a gas stove one day, but right now I have an electric stove, and I'm starting it just between 3 and 4, all right, just to start off. We're actually going to increase that temperature later on, but I'm starting off my heat very, very I would say moderately low, all right? And I'm using a saucepan here, all right? But you are also welcome to use a pot like this, which seems a little weird to cook an egg, all right? And if I was going to fry an egg, I definitely wouldn't use a small pot, but if I wanted to cook scrambled eggs, which is what we're doing, by the way. We're scrambling the eggs. That's exactly what I'm doing. But the first thing I want to do, all right, is talk a little bit about kitchen safety, especially because I'm talking with kids, all right? And so I did work for a while in a restaurant. And I'll tell you, one of the biggest things that you need to be worried about, all right, is hygiene. So I'm going to go ahead, I'm going to wash my hands, all right? Our hands actually have tons of good bacteria on them. There are two types of bacteria, Staphylococcus aureus and Staphylococcus epidermis, if you want to get really nerdy about it. And that prevents a lot of bad bacteria from growing, but we touch so many shared surfaces. One of the things I realized once COVID hit was how often I touch my face, right? And you don't want me touching my face and then cooking your food. All right, that's a little bit gross. So the first thing I'm going to do is I'm going to wash my hands. That's going to be my first step of food safety. I also know that I've touched plenty of surfaces that other people have touched, and I don't know what they've touched before. So I'm going to wash my hands, warm soap and water for just about. All right, so hands are nice and clean. That way that I'm not giving you bacteria. I've had food poisoning before. There are other types of bacteria that cause food poisoning, some of which are actually present in eggs, all right, because birds tend to carry different types of bacteria than humans, such as salmonella. I've had salmonella before, and 0 out of 10 do not recommend. It will knock you out for a couple of days. But that being said, so I wash my hands. Let's talk a little bit more about food safety. All right, this is what I learned working in a restaurant. All right, is that you want to be watching out for, all right, first of all, sharp things. All right, sharp things present a danger. All right, to you, that should seem pretty obvious. All right, the next thing you want to watch out for is hot things, such as the stove we're working on, the stove that's on right now. All right. The next thing you want to watch out for is slippery things, because there are plenty of times water from the sink that we just washed our hands with. Some eggs could get on the floor. We want to watch out for slippery things. And we definitely don't want to combine those things together with other people. All right. The first thing that got me yelled at when I worked in a restaurant was walking behind somebody while they were reaching into an oven. So that's combining hot things with other people. And it got me yelled at very quickly. And so we just want to be aware of safety and our surroundings, general consciousness, all right, in the kitchen. All right, that being said, our pan is heating up. All right, so let's talk a little bit about what we're going to cook today and why we're going to cook it that way. All right. And so I have my eggs right here. I'm just going to cook 2 eggs, I think 2 eggs. Actually, I'm going to do 3. I'm going to do 3 eggs today, just so that we can see it a little bit better. I prefer the cage-free. There's no judgment if you aren't a cage-free egg user. And even the cage-free system is not perfect, but I'm for the humane treatment of animals. I think that it gives the chickens a little bit better life if they are not locked in a cage. And like I said, it's not a perfect system. I'm aware of how the farming industry has changed. And even when I'm home, I have the advantage of my parents actually own chickens. And so I get free eggs there. They still have young chickens that lay every single day. The cool thing about my parents' chickens, they lay brown eggs just like this. They actually have sort of like an antibacterial film that comes around the outside of the egg that gets washed off in commercially produced eggs. And so their eggs actually stay good in the refrigerator for like 5 months if they don't wash the eggs off. The problem is that some of that film actually has some bacteria on it. So it's one of those things that you need to wash if you're using farm fresh eggs. All right. So first thing I'm going to do, all right, is I'm going to crack my egg. All right. I'm going to crack 3 eggs. All right. Just into my bowl. Oops. I dropped a little bit of a shell. That's okay, because it just happens sometimes, right? And There actually is. So this is one misconception here. So pretty frequently, especially in like cage-free eggs, I don't know if you're going to be able to see it very well, but there's a brown protein spot in there, right? I can't remember the exact cause of it. Sometimes you'll see blood spots in the yolk, all right? But this is just a protein spot, and the blood spots are caused by a broken blood vessel as the egg is laid. These are protein spots just caused by sort of a coagulation of certain types of proteins. All right, so I've got one egg cracked. I've got 2 eggs in my bowl. All right. And my 3rd egg. All right. So I've got 3 eggs. All right, and I actually forgot to grab a fork before we started, but I like to use a fork. Before I started stirring these things up. And so the first thing that I want to do is I want to stir all my eggs up, all right? I forgot to mention before, all right, the yellow part, the yolk, is made up of mostly fats, all right? From a lower understanding, all right, or lower school understanding, fats nutritionally carry a lot of energy, all right? So fats carry a lot of energy. Right? That's an upper school nutritional understanding too. And so humans are kind of hardwired to love the taste of fats. Because think about it, for thousands of years, humans had to work so hard for food. They couldn't just run out to the Harris Teeter, to the Trader Joe's, to the Food Lion, wherever you get your food from, or even the farmer's market across the street. All right, they had to work a little bit harder for their food. All right, and so we're hardwired to love foods that make life a little bit easier for us. All right, and so fats are one of those things because you can get more energy and less food. All right, then that's just a little bit less work you have to do. So the yellow part, the yolk, has some fats in it. It has some good fats in it for if we want to get a little bit more complicated, the omega-3 fatty acids, which are a little bit better for things like brain health and stuff like that. Eggs also contain some vitamins that are actually fat soluble, which we'll talk about that in a second. The difference between fat soluble and water soluble, which is sometimes called polar and non-polar as well. All right. The clear part around the outside of the egg, when we first break it, that's mostly protein. Proteins are just a general term for the building blocks that make us up as animals. All right. And so your skin is made up of skin proteins. All right. Your muscles are made up of muscle proteins. All right. And so what your body does when you eat proteins is it actually deconstructs the proteins that are building something else, takes those building blocks and builds you so that you are literally what you eat. All right. And so I'm stirring my eggs and my yolk together. I'm stirring my egg whites and my yolks together. The whites are the clear part. All right. And that's because when you cook them, they turn white. All right. Until they create what's called an emulsion. All right, which is a mixing of a polar and a non-polar substance. All right, normally they're separated, right? When you first crack an egg, right? And that's because polar just means that a molecule is charged. And this is more for my upper middle school kids as they're starting to learn a little bit of chemistry. They start to learn a little bit about molecules. Polar just means that a molecule has charges, it has positive and negative charges. Non-polar means that it has no charges, right? And so fats are the classic example of something that's non-polar. And so charged molecules and non-charged molecules don't normally like to get together unless we force them to, in which case that's what we call an emulsion, right? And sometimes you have other proteins and stuff that help along. All right, so I like to keep my emulsion nice and stirred together this entire time, all right? And so we're getting ready to cook, right? And so one last thing I want to talk about before we actually start the cooking of these eggs, we're going to add 1 or 2 more other things to it, all right? This is one of the books that sort of helps me understand science. This is not a a paid advertisement by any means. They are not a sponsor, but this book called Salt, Fat, Acid, Heat, I think makes the understanding of science behind cooking a little bit easier. So I do recommend it. It's helped me understand science. All right. And so we talked a little bit about fat. All right. And fats in food help us transfer flavor a little bit more. And so we're going to see fats in not just the yolk of the eggs, but in a couple of different ways. All right. We talked about heat, how we don't want to add too much heat early on. All right. And so the next thing that we want to talk about, all right, is salt. And so I have some of my Morton kosher salt, all right, which is just a little bit thicker ground salt. All right. It's not as fine as regular table salt, but regular table salt's fine too. This is just what I kind of had on hand. All right. Oh no, my box is a little bit broken, so I'm going to do this over the sink. All right, and so I'm just going to grab a pinch of salt, all right? And the goal is not to make the eggs salty. So here's the misconception, all right? Salt in food can make food salty, all right? But the purpose isn't necessarily to make it salty, all right? So we have flavors in the eggs that are going to be polar and some are going to be nonpolar, all right? But the salt is going to help draw out some of those flavors, all right? If you think about salt draws out water. All right. So if I took this salt and just ate this pinch of salt right now, it would draw a ton of water out of my mouth. It'd make my mouth very dry. All right. But salt draws out flavor in the same way. And so it's going to enhance flavor. All right. Fat is going to help transmit that flavor too, in a way that we're going to. All right. And then heat is going to help us cook the food properly. The only thing that we haven't talked about is the acid. All right. And that's a little secret ingredient. I'm not using any today. All right. But if you have some at home, you can. And you can add a dash of lemon juice. All right. And that dash of lemon juice isn't going to make it taste like lemon. All right. What it's going to do is it's going to help balance the flavors throughout. All right. And so that's the purpose of acid in food, is it actually can help mellow out food a little bit. Acids actually do taste a little sour. So I don't know if mellow out's the right word, but it helps all the flavors sort of go together, even out. And so, like I said, I'm not adding any today. I'm just adding about a pinch of salt to my eggs, all right? Not to make them salty, but to draw out that flavor. All right? And salt defined in chemistry, all right, when we have table salt, all right, so we have a positive sodium ion and a negative chlorine ion. All right. And this is a great example, all right, about how everything is chemicals. All right. I hear sometimes we think about things that we should be scared of chemicals, but this is a great example about how chemicals aren't necessarily a bad thing. I'm not a big fan of eating food with a bunch of stuff that I don't totally understand either. All right. But let's think about sodium chloride for a second. All right. Sodium by itself, all right, if I just found sodium out in nature, which you actually can't because it's so reactive, all right, in fact, it is so reactive that it will cause an explosion if you put it in water. And then you have chlorine, which by itself, all right, is a toxic gas, all right? Yet somehow when they bind together, all right, to form these sodium chloride, they produce table salt. And so it's a totally new substance, all right? And so just because we see, when we talk about sodium in a form, doesn't mean that we're necessarily talking about just sodium. We're talking about sodium chloride here, which is a totally new substance, all right? This is more for our people who are studying chemistry. But let's move on to a topic as we start to cook the eggs, all right? Let's start on to a topic that really appeals to everybody, all right? And because I feel like I've had a little bit of love for the upper school kids the past couple of times, but I've got my pan right here, right? And I'm going to talk about 3 different methods of heat transfer, all right? I talked about this with my physics class, but I feel like I could also talk about this with a 3rd grader, a 4th grader, a 5th grader, all right? And so there's 3 different types of heat transfer, all right? The most obvious is that if I was going to touch this pan right now, it would be hot. It would also be violating one of our kitchen safety standards. All right. And that transfer of heat through contact is called conduction. All right, the transfer of heat through contact is called conduction. All right, and we see this by this metal pan is in contact with the hot stove, and my hand was to touch it would be in contact with it. All right, the next type of heat transfer that I want to talk about is radiation. All right, and that's heat that just sort of radiates naturally away. So I can feel this heat from a distance. All right, I can feel it from the sides here. I can feel it from the top. Once again, I'm being careful. All right, because we've got hot stuff right here. We've got sharp stuff over there. I'm making sure not to slip on anything. And so we've got hot stuff, sharp stuff, slippery stuff all around. We want to be careful in the kitchen. All right. But so we talked about conduction, heat transfer through contact, radiation, heat transfer through sort of the natural emittance. All right. This happens through electromagnetic waves that sort of emit the heat as energy being sort of dissipated. And the last is how our eggs are going to cook today. All right. And that is heat transferred through a fluid. All right. And so heat transferred through a fluid is called convection. And so when we talk about a fluid in physics terms, all right, we aren't just talking about water or a liquid, all right? We're talking about anything that flows. And things that flow are liquids and gases, all right? And so some people may have a convection oven, and that heats up some of the air. And as that air moves around, it's going to transfer that heat. I know air fryers have been kind of the big thing lately. And they work by heating up some of the air and then blowing it around the food. All right, and that's a form of convection. So, all right, you can either take your butter or a non-stick spray. All right, now I've still got my egg emulsion. I just put a little salt in there. I told you today I didn't put in lemon juice because I'm out of it in my kitchen. But I might put a dash of lemon juice in the future, all right, to add an acid in. But I'm going to spray some nonstick spray. If you don't have nonstick spray, that's okay. You can always just add butter. I'm using this vegan butter today because my daughter actually has a dairy allergy. And so that's just what I have on hand. So I'm going to spray my pan with the nonstick spray just because it's going to make my life a little bit easier. All right? I can also do it with the butter. It's the same thing. We're just trying to create a barrier that doesn't stick, so that our eggs don't stick to the pan. All right. Next thing is I'm going to take my emulsion, my mixture of the fats and the proteins, the polar and non-polar substances. All right, and I'm going to pour them into my pan. All right. One thing about heat transfer, all right, is that the more surface area you have, all right. Oh, by the way, while I'm doing this, I want to be stirring the entire time. All right, I want to be stirring the entire time. And even this feels a little hot to me. So this feels a little hot to what I want. So I'm going to turn it down a little bit. All right, and so I want to keep stirring the entire time. So I turned mine down to a 3. A 4 was a little bit hotter than I thought because of actually the principle that I'm telling you right now is that a greater surface area will actually transfer heat faster. All right. Also, having different materials. So some materials work as thermal conductors, and some materials work as thermal insulators. So some materials make it easier to transfer heat, and some materials make it more difficult. All right. So the next thing I want to do is I'm going to add a little bit of butter. All right. I'm going to add 1 tablespoon per egg, which seems like a lot, and it is. All right. So portion control is essential when we're talking about eating with a lot of fats. All right, so there's nothing wrong with a little bit of fat as long as we are eating the correct portions of that fat, all right, and maybe not all the time. All right, and so I'm putting in a little bit of butter and I'm stirring that into my eggs. Like I said, I want to keep stirring pretty much the whole time so that one part of the eggs doesn't undergo this chemical reaction of denaturing faster than the other parts. All right. And so I use my whisk here. right? And I make sure that the butter is kind of getting mixed in all together as those eggs, proteins denature, they change shape. I'm getting a different substance here. You can tell because I started with a liquid and ended up with a solid, all right, even though I added heat, which shouldn't happen if you know about states unless we have a chemical reaction happening, right? And so if you look at the eggs that I'm cooking right now, all right, none of them are stiff. None of them are getting too hot in one spot. All right, they're smooth and they're creamy. All right, and a big part of that's due to the butter. All right, but when you start seeing like them get crispy in one spot, like an omelet or something like that, that's not really what you want with scrambled eggs. All right, and once again, we have the salt in there. That's really going to bring out a lot of the flavor too. The butter is going to help transfer flavor. Butter has a lot of fat in it. And like I said, us humans, we're hardwired. We've evolved to really like fat because that means that's less work and more energy for us. All right, but we also got to be careful with fat because maybe we aren't doing as much work for food as we would have a couple thousand years ago. All right, so I'm going to go ahead and take mine off the heat because they're looking pretty done right now. All right. General rule of thumb, if you're using a food thermometer, maybe because you're new to this, is that you want it to be at you want it to get up to over 160 degrees to kill the bacteria. Otherwise, they definitely risk the chance of salmonella. The other thing you want to watch out for in kitchen safety is cross-contamination. You don't want dirty things to touch clean things, but these eggs are done. So one last thing that I'm going to do, all right, is I love to put my eggs on some toast. And so I'm going to go ahead, and this is less scientific, all right? But actually, let's talk a little bit about the science of it. So we have some sourdough bread here, all right? And you may notice, all right, so looking up close, you see all these little bubbles, all right? Those bubbles are actually caused by yeast, all right? So sourdough bread, for me, as a scientist, always reminds me of my time in microbiology lab where I spent studying yeast, all right? And so there's a specific type of yeast that goes into bread. It also goes into beer, all right, called Saccharomyces, all right? And Saccharomyces really likes to eat carbohydrates, which are just molecules with carbon and hydrogen together, and they're present in a lot of sugars. And so, and a lot of flours and stuff like that. When I say flours, I mean like flour as in like cooking flour, not pretty flowers. And so the cool thing is that when we think about microorganisms, we think about the reason that we washed our hands to start with. But really, microorganisms are present in a lot of the foods that we eat. In this case, we have the bread, all right? And so those bubbles in the bread are actually created from the yeast eating some of the wheat flour, and then undergoing a process called fermentation. And as it ferments, it sort of burps out carbon dioxide. And as it burps out carbon dioxide, it creates those nice fluffy bubbles, which causes bread to rise. And it's also, so while working in a lab with a lot of these Saccharomyces yeast, which are very present in many microbiology labs, you become very familiar with the smell because it smells almost like sourdough bread. And so I like to put my eggs on a little bit of toast, all right? And I like to enjoy that. So bread is mostly a carbohydrate nutritionally. We talked about carbohydrates already. Carbohydrates actually serve mainly as, they're actually one of the 4 biological macromolecules. We have proteins, which we talked about. We have fats, which we talked about, or lipids. And we have carbohydrates, and carbohydrates serve as an energy source for pretty much all organisms in some way, shape, or form. All right. And so we're kind of hardwired to like them as well because they provide energy for us. It's the same reason we like sweets, because sweets have a lot of carbohydrates in them in the form of simple sugars. And so eggs on toast is going to be a pretty nice balanced meal. Like I said, it does have a lot of fat in it, so we've got to be careful about our portion control. But other than that, pretty nutritious in a couple of different ways. And so my toast is popping up now, and I'm going to go ahead and plate it. All right. My general rule of thumb, all right, when it comes to making toast is I like to use bread that I would eat by itself. All right. And I feel like some people might butter their bread already, but I feel like I have enough butter in the eggs to be able to make sure that the bread is nice and moist. All right. So I'm definitely also going to get a fork out because I've got more eggs than bread, as you can see here, but this is my finished result. All right. So I'll add a little bit of pepper on top and I'll be done. All right. And that's about it for the how to cook an egg with Mr. Egg. Hopefully you learned some science along the way. We learned, first thing we learned is some of the biological macromolecules, the fats, carbohydrates. We talked about proteins. The fourth one, by the way, is nucleic acids, which are in our DNA and RNA, right? All living things. We learned about heat transfer, which is pretty much the most essential thing when it comes to cooking an egg. And so we talked about how we have convection, conduction, and radiation. And then we also talked about how some of these other elements, such as salt, draw out flavors. And salt, in this case, is sodium chloride, but salt chemically is going to be anything that sort of any charged substance that sort of dissolves in water. All right. And so there's a lot of science to cooking. There's a lot of things that will make your cooking better. I realized that after decades, I'd been cooking eggs wrong. And so I hope you learn to cook eggs and hopefully you enjoy them as well.
Christian, that was amazing. I learned a tremendous amount during the course of that. It was an excellent presentation. It had an extraordinary amount of information in it. We may get a question or two here.
Okay.
Do you have a question? We're looking through the chat now, but we were really amazed listening to you give the presentation. We're going to have to change the way that we cook our own eggs, and I think everybody else who sees this video is going to end up wanting to do the same.
Yeah, I find the creamier texture of scrambled eggs is a little bit better. If you're cooking fried eggs or omelets or something like that, it's a little bit different in your approach to heat. But heat is really the key to a lot of good cooking.
Mm-hmm. So there was a question about the lemon juice and adding the acid. What was the reason for that?
Yeah, let me go straight to my source. So the best description I can give is that acid helps balance out flavor. So it's not about tasting acidic, although acids and bases are sort of chemicals that have been traditionally defined by their taste. Bases taste bitter, acids taste sour, and so we see acids show up a lot in cooking in the form of like dairy products, because a lot of dairy products have a lot of acid in it, like yogurt and cheeses and stuff like that. And if you think about what those things do, not necessarily lemon juice, but which is also acidic, but if you think about what dairy does, all right, to add, or how it changes food, is it helps sort of blend the flavors, all right? And so I'm trying to find my best definition, all right, in here, in my book, all right, and so, because I'm trying to think about ways that acid shows up in food. So it shows up a lot in dairy products. It shows up in the form of lemon juice, and so things like vinegar and stuff like that. And so, what acid does is it helps balance the flavors. And by that, I mean, it helps you taste sort of each of the ingredients individually. And so where one ingredient may be really overpowering, it's not going to be as overpowering. It's going to help mellow that ingredient out, which is going to help you taste some of the other ingredients. And so in the eggs, it's going to help you taste the butter a little. It may make you actually taste the butter a little bit less, and some of the protein of the eggs a little bit more, where you may be very focused on the fat of the eggs. And so salt enhances flavor, but acid balances the flavor so that you're getting a little bit of everything in the food. And I think about it in the terms of, if you've ever had good chicken wings, like if you've ever had good chicken wings and you dip them in ranch, all right, they become a little bit more mellowed out. You don't get overpowered by the buffalo sauce anymore, and you start to taste the chicken a little bit more, and you get to enjoy the ranch. And that ranch is actually acidic, and that's part of why that happens.
Speaking of buffalo sauce, what do you like on top of your eggs? Do you go plain, or are you a ketchup, hot sauce?
Totally depends on the eggs. I definitely grew up a ketchup on eggs guy, which is surprising. I've heard that's a more northern thing, but I'm a little bit of a redneck from North Georgia, so somehow I'm not sure how I got that, but I definitely grew up a ketchup on eggs guy. Now I'm just a pepper guy, or I'm a big fan of the everything bagel seasoning from Trader Joe's, which is just the seasoning they put on the everything bagel with like the sesame seeds and all that. And I'll cover it with that.
I'll say Trader Joe is not a sponsor, but they're welcome to if they'd like to.
Yeah.
So we'll pass that on to them and give them an opportunity.
Yeah.
We had another question here. One of the people watching wanted to verify: were you on low heat the whole time, or were you changing the heat through the course of cooking?
Yeah, so for this one, I actually stayed on low heat the whole time. And the reason was actually different than what I would normally do. And so it was one adjustment that I actually had to make. And I'm glad that question was asked. And so I was using a very wide pan.
Mm-hmm.
And using that very wide pan, it transfers heat very fast because it has a much bigger surface area. If I was using a pot, which a lot of chefs actually like to do. So the first time I saw someone make scrambled eggs differently was actually Gordon Ramsay. And he used a pot, and I thought that was really weird, but I'm not going to question Gordon Ramsay for fear of being called an idiot sandwich or something like that.
Gordon is also not a sponsor.
Yeah,
but
also
he can be if he'd like to.
Yes. And so in the pot, it transfers heat a little bit more slowly. So I found that even on low heat, the heat was starting to transfer very fast. And so I was watching the eggs, and they were starting to clump together. They were starting to denature already on that low heat. And so I didn't want to turn up the heat. Frequently, when I use the pot, though, I do have to turn the heat up even to get the reaction to happen. So it's just a matter of finding to see what's the lowest heat that we can cause the reaction to happen, because we want it to happen slowly, because eggs can burn really easily. They can get sort of that crusty film, which I don't really like the flavor of. I don't really like the texture of. And so normally I would slowly, gradually increase the heat, but with that really wide pan and that wide surface area, it transferred the heat really fast already.
Excellent.
Is there a difference in cooking on electric versus gas or, say, a campfire stove?
I know that gas tends to transfer heat a little bit faster. So gas stoves tend to get a little bit hotter a little bit quicker. And I haven't really thought about a campfire stove. I think it would depend on how close you are to the campfire, and that sort of thing. But you definitely would get some different flavors with a campfire stove. So you get the benefit of the smokiness of the wood. So depending on what type of wood you're using, would definitely have a huge impact on whatever you're cooking.
Well, that was great. That was really informative. We're gonna wrap it up here, but I just want to take a opportunity first of all to thank you, Christian, for bringing us this lesson today. I think a lot of people are gonna enjoy watching it both live here on the stream and then over the next few weeks on the SteamFest website. Speaking of the SteamFest website, wsteamfest.org has over 100 fun and free hands-on activities in the areas of science, technology, engineering, arts, and mathematics. Youth K through 12 can register at wsteamfest.org, complete activities, log into your journal, earn badges, and win prizes. Today's presentation with SteamFest is sponsored by Woodlawn School, who started the SteamFest project. We're very fortunate to have them make this possible. If you're watching today, or if you're watching on the recordings later, you can go to your journal, log, answer the journal questions, and qualify for the daily prize drawings. And I also want to thank the people who have been working to make this stream possible today. Shannon Blakely, the moderator, and Lena Patel, who's been watching remotely and making sure that it was running smoothly. And on that note, Christian, we'll sign off and hope everybody has a good day. Thank you.
Awesome. Thank you so much.